Hi, in this video, we are going to talk about the RC phase shift oscillator. This is a simple circuit that generates sinusoidal signals using resistors and capacitors. Let's dive in and understand how it works. The RC phase shift oscillator works by feeding a part of its output back to the input, after introducing a phase shift of 180 degrees through an RC network. When combined with another 180 degrees provided by an amplifier, the total phase shift becomes 360 degrees, or 0 degrees. This satisfies the Barkhausen criterion, which is necessary for sustained oscillations. The main components of this oscillator are as follows. First, the amplifier. It is typically a transistor or an operational amplifier, also called an op-amp, which amplifies the signal and adds the first 180 degrees phase shift. Second, the RC network, which consists of 3 or more resistor-capacitor sections connected together. Each RC section adds a phase shift of 60 degrees, for a total of 180 degrees. Finally, the feedback network, which ensures a fraction of the output signal is sent back to the input to sustain the oscillations. Now, let's understand how it works step by step. Initially, a small noise or transient signal is amplified by the amplifier. This signal then passes through the RC network, which introduces a phase shift of 180 degrees. The amplifier adds another 180 degrees of phase shift and increases the signal strength. Together, these create a total phase shift of 360 degrees, and the amplified signal is fed back into the circuit. This loop sustains the oscillations. The frequency of oscillation depends on the RC network and is calculated using this formula. Frequency equals 1 divided by 2 times pi, times r, times c, times the square root of 6. Here, r is the resistance in ohms, and c is the capacitance in farads. By adjusting r and c, you can change the oscillation frequency. For example, smaller resistor and capacitor values are used for higher frequencies. The RC phase shift oscillator has several advantages. It is simple, inexpensive, and generates stable sinusoidal signals. However, it is not suitable for high frequencies and its amplitude stability depends on the amplifier's gain. This oscillator is commonly used in audio signal generators, function generators, and other low-frequency applications. And that's how an RC phase shift oscillator works. Thank you for watching, and I hope this explanation was helpful.